Good morning, everybody. Today's topic is electric potential. On the previous sessions, I already discussed about Gauss' law in electrostatics, Coulomb's law in electrostatics, and their applications. Now, I am going to discuss about electric potential. I hope you all enjoy my videos. Then please subscribe my channel and click the bell icon, and please like my videos. So I am starting our discussion. Let Q be a point charge at a point O. Let Q a positive point charge. Then the plus Q charge creates an electric field in this region. Now let us consider another point P. To find out the electric potential at the point P, we have to bring the unit positive test charge from infinity to the point P. From infinity to the point P, then the amount of work done to bring the unit positive test charge from infinity to at the point P is equal to the electric potential at the point P. Okay. Now, to bring the plus Q charge, plus Q test charge to bring from infinity to the point P, the work done is W. Therefore, W is equal to potential, electric potential at the point P into amount of charge Q. Amount of charge Q, where W is the work done to bring the plus Q charge from infinity to the point P. Let V be the electric potential potential at the point P. So therefore, W is equal to V into Q. Therefore, W is equal to V into Q. This is the relation between work done and electric potential. Now, we consider another point R in this electric field. Let dV be the potential difference between the 2 points P and R. Therefore, to bring the charge plus Q from the point P to R against the electric field, the work done is dW. Okay. Therefore, dW is equal to Q into dV. This is the relation between work done, charge and potential difference. Unit of V is, or potential difference of potential is, volt in SI system. Therefore, 1 volt is equal to 1 joule per 1 coulomb. Now, the dimension of V is M L2 T minus 2 by current I into T. This is equal to M L2 T minus 3 capital I minus 1. This is the dimension of electric potential. Now, the next topic is the relation between electric potential difference and electric field. Our next topic is relation between electric potential difference and electric field. Okay. Let plus q point charge is placed at a point O. A and B are two points which point collinear with the point O. That is point O, A and B are collinear. OA is equal to R and AB is the small distance dr. OA is equal to R and AB is equal to dr. Let potential difference between A and B is dV. Capital E is the electric field between A and B. Dr is the very small distance between A and B. Since A and B are very close to each other, therefore electric field at point A and at point B are same. Okay. Now work done to bring a plus q point charge from point P to the point A is dW. So therefore, we know dW is equal to Q into dV, where dV is the potential difference between A and B. This is equation number 1. We know the work done is also equal to the force into displacement, force dot displacement. Now the repulsive force acts on plus Q charge is F. Therefore, F vector is equal to electric field E vector dot Q. Now, therefore, work done dW is equal to force dot displacement dr. We know the displacement occurs from point B to A. Therefore, angle between the force and displacement is 180 degree or pi radian. Therefore, F dr cos 180, because the displacement occurs there from B to A and the electric field or electric force acts from A to B. This is equal to minus F dr. This is equation number 2. Now, equating equation number 1 and equation number 2, we can write minus F dr is equal to Q dV, or we know F is equal to EQ, therefore EQ to dr is equal to Q dV, or we can cancel or divide Q on both sides. Therefore, E is equal to minus dV dr. Since electric potential V is a function of R, therefore we can also write E is equal to minus dou V dou R, where R dou represents partial derivative. Okay. If this changes occurs only x-axis, therefore we can write therefore along OX axis electric field EX is equal to minus dou V dou X. Along OY axis electric field EY is equal to minus dou V dou Y. Along OZ axis electric field Ez is equal to minus dou V dou Z. So therefore resultant electric field at a point E is equal to minus within first bracket dou V dou X I cap plus dou V dou Y J cap plus dou V dou Z K cap, or E vector is equal to minus dou X I cap plus dou Y J cap plus dou Z K cap V, and this is known as del or nabla. Where del or nabla is equal to dou of dou X I cap dou of dou Y Z cap plus dou of dou Z K cap. This is the relation, this is the complete relation between electric field and electric potential. That means gradient of a electric potential or negative gradient of an electric potential at a point is equal to electric field at that point. Now the next topic is to find out the electric potential at a point due to a point charge plus Q. Similarly, let this figure is similar to the previous one. Let plus Q be a point charge at a point O in air medium. A be a point at a distance r from the point O. A B is equal to dr. E be the electric field at a point A. E capital E be the electric field at uh, at the point A. dV be the potential difference potential difference between A and B. A and B. We know E is equal to minus dV dr. We know E is equal to minus dV dr. Again, we know magnitude of electric field due to a point charge in air is equal to 1 by 4 pi epsilon 0 q by r square. Therefore, dV is equal to minus 1 by 4 pi epsilon 0 q by r square into dr. Now, according to the definition of electric potential at a point, we are to bring a positive unit test charge from infinity to the point A. The electric potential at the infinity is 0 and at the point B. Therefore, integrating both sides, we can write 0 to V dV is equal to minus q by 4 pi epsilon 0 integration of dr by r square at the infinity to r. The potential at infinity is 0, at the point r is V. Now, integrating with both sides, the result is V is equal to minus q by 4 pi epsilon 0 1 by r infinity to r. Okay, minus this is equal to V is equal to 1 by 4 pi epsilon 0 q by r. This is the relation between electric potential at a point due to a point charge Q. Minus comes out and this equal to plus 1 by r minus 1 by infinity. We know 1 by infinity is equal to 0. Now the electric potential difference between the 2 points due to a point charge. Similarly, let Q plus Q is a point charge and AB are 2 points. The position of A point is RA from the point O, and the position vector position of B point from O is RB. Therefore, the potential difference. Here, potential means electric potential. The electric potential difference between A and B is V is equal to VA minus VB is equal to Q by 4 pi epsilon 0 1 by R A minus 1 by R B. Okay. Now, we are going to find out the electric potential at a point due to an electric dipole. Let A be an electric dipole at the point A minus Q point charge is placed at the point B plus Q point charge is placed. O is the midpoint of AB and length of AB is 2L. The polar coordinate of the point P with respect to the point O is r theta. Let the distance PA is equal to under root of L square plus R square plus 2 RL cos theta, and the distance PB is under root of L square plus R square minus 2 RL cos theta. Okay. Now, the electric potential potential at the point P is V is equal to 1 by 4 pi epsilon 0 Q by PB minus Q by PA. Now, putting the value of PB and PA, we can write V is equal to 1 by 4 pi epsilon 0 1 by L square plus R square minus 2 RL cos theta minus 1 by whole to the power half minus R square plus L square plus 2 RL cos theta whole to the power half. Okay, this is half. This equal to, we can write 1 by L square plus R square plus 2 RL cos theta whole to the power half minus L square plus R square minus 2 RL cos theta whole to the power half. By L square plus R square whole square minus 2 RL cos theta whole square whole to the power half. Now, by applying binomial theorem, we can, and neglecting the higher order terms, since R is excessively greater than L. Since R is excessively greater than L, applying binomial theorem, we can write this is equal to 1 by 4 pi epsilon 0 P cos theta by R square, where P is the electric dipole moment where P is equal to 2QL is equal to electric dipole moment. This is the final expression of electric potential at a point into a point into electric lamp. And we know the electric potential of the earth is zero. And a conductor always acts as an equipotential surface. That means the electric potential at the every point on the conducting surface is equal. So what is equipotential surface? Let us consider this is an equipotential surface and AB are 2 points on this surface. Now potential difference between A and B is dV is equal to 0. Then this surface is known as electric known as equipotential surface. Okay. The characteristics of equipotential surface is the electric lines of force emits from equipotential surface always in normal direction. That is electric lines of force emits from the equipotential surface is always in normal direction. That is the electric field emits the direction of electric field at every point on the equipotential surface is normal to the surface. We can prove this statement. Let dV be the potential difference between A and B. To bring the plus Q charge from point B to A, the work done is dW. Therefore, dV is equal to Q into dW. We know that. Again, we know that work done is equal to work done F is equal to work done dW is equal to F vector dot dr vector, where dr is the displacement of the charge, while dr is equal to ab, the displacement of the charge. Okay. Therefore, f dot dr is equal to q into dv. But for equipotential surface, for an equipotential surface, potential surface, dv is equal to 0. Therefore, f vector dot dr vector is equal to 0. Therefore, f is normal to dr, and we know f vector is parallel to electric field vector E vector. Therefore, electric field also normal to dr. Therefore, electric lines of force always emits from the equipotential surface in normal direction. Therefore, the electric lines of force emits in normal direction from an equipotential surface. Equipotential surface. Okay. I hope you can understand the discussion of today's topic. In the coming session, I shall discuss about the electric potential energy. If you enjoy my videos, then please subscribe my channel and click the like button. Till then, wait for my next videos. Thank you for watching my video. Okay, bye.